Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Today I have a very quick troubleshooting and repair video to share with you. I was just going to buzz through this and get this done, but then I figured maybe you'd like to come along for the ride. So here we are. Let's fix this radio receiver. Here's the radio that we are going to troubleshoot and repair together. So this is very similar to the one that I own, and supposedly this one here was restored some years back. It failed and it was just put on a shelf, and as you can see, I've been drawing lines in the dust. So it's definitely been sitting for a long period of time. All that you see here is just from me handling this thing and the dust floating around. Look at this. So it's obviously been sitting. I have this thing plugged into my isolation transformer and current limited variac supply, and I'm ready to turn this thing on. So the complaint is the receive is just very, very low, and sometimes it's not even there. So I'll turn the thing on and let's see what we hear. So the dial's lighting up. That is a good sign. So I see the eye lighting up. That hum you hear means that the audio section's working. Oh, there are some stations in there. Very weak though, eh? Wow. Yeah, very, very weak. No eye deflection or anything. And it's, you can hear that, how distorted it is. Alright, let's see if AM happens here. Turn that down. And nothing there. Well, a little bit at the top end. Again, weak. Okay, so what do we know by what we've already seen here? Well, we know that the audio section is working because it has lots of hum when we turn the audio up. We know that there is B+, so the power supply is working in this to some extent because we can see the I tube is lit up, and if we don't have any B+ in the radio, obviously we're not going to have any hum for any audio. So we already know the power supply is partially working, it is partially receiving, we do have B+, the filaments are all lighting up in all the tubes or we wouldn't hear anything. We can see the dial lights are on, so we know the filament winding is okay in the radio receiver. And, you know, it's pretty much there. It's almost working. It's just not working the way it should. So this radio here didn't have a back side on it. Usually they've got like a cardboard back and some writing on it and things like that. So what I'm going to do is I'll get this thing turned around and we'll take a look in the back side and I'll start taking some measurements. All right, I got one of my favorite voltmeters. Let's get troubleshooting. Just before we get started, I want you to know that if you're following along, you're doing so at your own risk. Know that radio receivers like this and pretty much any equipment that has vacuum tubes in it has elevated plate voltages or anode voltages. So, for example, a radio like this may have 300 volts floating around in it, and it goes for anything with vacuum tubes, guitar amplifiers, radios, televisions, old test equipment, anything with vacuum tubes has elevated voltages. So again, if you're following along, you're doing so at your own risk. Be very, very careful. If you don't know anything about these things and you're starting brand new on something like this, I strongly suggest that before you go about working on something like this, that you do a little bit of studying and familiarize yourself with the circuitry and how these things work. Because if you do come across the B+ in these things, it's not pleasant. Okay, so what I'm going to do now is turn on the isolation transformer and current limited variac supply. Let all the tubes warm up here. And let's see what's going on here. I'll turn some of the lighting off so we can see the vacuum tube glow. Let's see here, get that out of the way, and maybe this. Oh, it's trying. This volume, I have this thing turned right up to the max pretty much. So it seems to be rather intermittent, doesn't it? So it is there. Every time I turn it on, it seems to get a little bit better. That's the problem with intermittence. So this thing here might all of a sudden start working and we won't have our culprit. So we got to be very, very careful with what we do. So the first thing that we want to do is we want to start looking for any type of voltage drop across the larger resistors. So there's this resistor up in here that looks like it has been very, very hot. So what I'm going to do is read both sides of that large resistor there. I'm going to get some lights back on here. As we can see, all the tubes are glowing nicely. All right, so ground to the chassis, like so. This is on DC. So let's measure one side of this kind of burnt looking resistor. So there's 265 volts on that side, and there is 314 on that side. So not too bad. So there's a bit of drop across that resistor. That's a 2-watt resistor. That's probably why it's been hot. This should be changed probably to something a little bit larger. So what we want to do, again, is just look for a drop across some of the larger resistors. I see one way back in here. I don't know if you can see that. I'll just move this here. Get a little bit closer. It's off to the side. So right in there is another one. So that's obviously going to be passing B+. So what I need to do now is reach back into my drawer here and see if I can find a piece of this tubing that will stop me from shorting my probe. So what happens is when you're poking, when you got really tight clearances here, you can see there's a shell of a looks to be an IF transformer, some writing on it. And as you can see, there's a lead down there. And if you, with a long probe like this, it's very easy to short that to the case. You don't want to do that. So what I do is I put a piece of fibrous tubing over this. And what it'll do is it'll stop me from destroying things. So I will grab a pair of clippers here. So I'll just show you what I do. Just size it up. Like so. All right. Clip it rather close to the tip. And then I will just slide that over the probe. Like so. And that'll be good right about there. Okay. There's a little bit of a gap down here. Not too bad. What happens is this stuff, because I've expanded it, it's kind of pulled together a little bit. But that's okay. That'll stop me from shorting on anything down in there. So what I want to do is see if there's any B+ on this side. And what do we have? Oh, maybe I should go to the chassis here, eh? Not very much, eh? That might be something for another mode, because so there's 263 volts on that side. And there's 1.2 volts on that side. That resistor has got to be very, very hot. That's quite a bit of drop across that. That doesn't look right. 262. So what I'm going to do now is I'm going to change the dial. Tip this forward, change this to AM, and see if something happens here. See if that maybe roots it. Let's see what happens. Try that one more time. Alright, so probably should get that off there and maybe put the focus on the actual meter so it's not hazy. Here we go. Alright, let's try that again. Looks like that froze my meter. It did. It froze my meter. That doesn't look very good, does it? What's that all about, Agilent? There it is. So it's in a different mode, so maybe dragging that off. Yeah, see, it's on both sides in the AM mode. So one's for AM, and the other side is obviously going through circuitry here. So that looks to be okay. 102 on that side. Okay, so that's just a different mode. Okay, so what we're going to do is go back to FM, because that was the complaint. FM is here. I think that was the jazz button that I pushed down as well. Yes, it says jazz. All right. Everybody likes jazz, right? Okay, here we go. Try one more time. Yeah, that must be just dragging that down. Interesting. So that is kind of suspect. That is kind of suspect. Okay, so another thing that we want to do is I just want to see, now this is one tube that you definitely don't touch. Okay, so any power output tube, you don't want to go touching these things because they are extremely hot. Any type of beam power tube or power pentode, power tetrode, you don't want to be touching these things. Is if you put your fingers on something like that, you are going to get burnt very badly. And it goes the same thing for any large power tubes like 6L6s or anything like that. The metal 6F6s are, I think I still have a scar on my hand from one of those. I think that is there from me bumping my knuckle against it. So, at any rate, that was a metal 6F6 in a previous restoration. So, I just bumped my hand on it, and it's like, didn't even really hurt, but just, I tell you, nice big burn. So, anyways, very, very hot. So, you definitely don't want to touch the glass on these things. Now, these tubes here are running at, obviously they're not running anywhere near as hard as these things. So, this one here is almost cold. So, this one here, I can feel, that's basically filament power in this one. And when I mean cold, I mean cold. So the filament is lit. I can see the filament, so there's obviously no B+ on this tube. Big hint right there. That is hot. And that is hot. This one is almost cold. Almost cold. I would classify that as lukewarm water. Okay, that's about the heat on this tube right here. So whenever you have a tube like this, you can use a FLIR or whatever. If you have that adapter for your phone, you can use one of those for these things and look around and if you're more comfortable with that. A lot of the times, you can, just by doing this around a power tube, just putting your hand like this, you can feel the heat coming off of this. That tube is hot. So this one here, again, just whatever makes you feel comfortable, I guess judging temperatures of these things. So I've been doing this for so long, it just comes second nature. So I'm imagining that the problem is in this stage here. So we know the audio section works, right? Right, because of the output, and we do have sound, and there's a little bit of FM happening that would indicate why this tube is nice and hot. So that is for FM reception there, down in there, and we have another tube back in here. You see that? I just came very close to that thing, and it's hot. And this one here is obviously working as well. So no problems with any of these tubes. Is this fella right here that isn't receiving any B+. So now what we want to do is we want to look for larger resistors or resistors standing off of the printed circuit board. Usually those are the ones that carry B+ or get hot. And so what we're going to do is, this is for the audio output tube, so there's going to be a bit of a drop across that. I imagine probably 4 or 5 volts, something like that. Let's see how close I am. Okay, so that'd be the ground side. And that would be 6.7, not bad. Not bad. So, yeah, the audio tube is working just fine. Nice and strong. No problems there. So, let's take a look around this area here and see what we can see. There's a resistor standing up right in the back there. I don't know if you see that. I'll see if I can zoom on into that. Just have to move this into the center screen, and I'll move my focus over here. Pardon the shaky camera as I'm moving that around. And there you can see that little resistor right back in there. All right, that's one standing up. Okay, so let's take a look at what we have here. I don't know if I'm going to be able to get the voltmeter in this. So what I'm going to have to do is bring you a little ways away from this again. And I'll put this here. Hopefully you can see that okay. It's always kind of fun to see how quick you can find the problems in these things. Well, that's a B+ on that side. And now what I need to do is somehow get onto the other side, which I believe is right there. That's it. Nothing. And that is a very small resistor. Okay, so it's looking like we probably have a problem in this stage right here. Somewhere between that area, right? Because we have very low voltage over here, which could very well just be switched. There might be something switching this right now. And then, of course, we have over here, there's just nothing. So that resistor back there is very suspect. That one looks, it's a metal film resistor back there, and in a different mode it is working, so I'm not worried about that resistor. This one here is very suspect. It's small, and it's one of those old ones. So what I'll do is I'll turn this back to AM again, like we did for the other one, and see if we can see the voltage across that. I doubt that's going to change. Okay, so put that back in there, and we'll test this side here. So there's the B plus on that side, 282. Okay, move this out of the way. Hopefully you can see that, and get to that resistor leg back in there, which I do see. Where is it? Come on. Right there. I got 5 volts. So that is the problem. I'm pretty sure at this point that is the problem. That resistor back there. This tube is cold, and this is obviously going to be somewhere in the anode supply. So what we're going to do now, shut this off and make sure that the B plus has gone away in this thing. So there's lots of the rest of the circuit. This thing here will bleed off the B plus very quickly, the power output tube. Let's put this in here. So, okay, so I'll just test for B plus. Has it gone away? We're down to 1.7 volts there, and see what's over here. And we're down to 1.8 over here, no problems. So the B plus has gone away comfortably. Okay, so this is plugged into my isolation transformer. Current limited variac supply. I could even just leave that in with it off, but I'll do this just for demonstration purposes. So the nice thing about these things is they made the boards so that they can come out rather easily. So that here, you just get a nice pair of sharp clippers and take these little plastic, kind of like little plastic pins out. Show you something really neat about this. These European radios were really neat for this. So check that out. Wouldn't it be nice if the all-American 5s were that easy to service? Look at that. So the only thing is one piece of coax back here. And that's the resistor in question. Just kind of floating there. Okay, so let's take an ohms measurement. Because this is a high impedance circuit, there's a really good chance that we can test this right in circuit. Now, solid state equipment, you really can't do this a lot of the time. Sometimes you can get away with it. Almost, I would say 95% of the time you can test resistors in circuit in this vacuum tube gear. Solid state stuff, it's more like maybe 5% of the time because it's always going through other circuitry. You got voltage dividers and anything with transistors and all that stuff in it is usually lower impedance circuitry. So there's, it's just the way that they're wired and they're hooked up. You'll find that the resistor will attach to something that will change your resistance reading. All right. Wow. My leads are working, are they? Yes, they are. Okay, let's try this one more time. Yes, I would say that resistor is faulty. That is going to be a problem. So we're going to have to change that resistor out. Let's test that one in the back too, just while I'm at it. Let's see, what is the resistance of that thing? It looks like it's, pardon the noise here, it's dragging on my lamp. That looks like it is 27 k ohms. Let's see what we get here. So this is off. Let's see if we can get 27 k out of that. I need to make contact with the lead there. 26.8, close enough. So that resistor's absolutely fine. There's obviously some switching going on in there. I think we found the problem. This resistor right here. So now what I'm going to do is see if I can locate a schematic on this, and if not, I'll just draw this up. I imagine it's some form of a low value resistor, probably in line with the B+. Since the tube is cold, that means that there is no anode or very little anode voltage on this thing. So, well, you know what we can do is we can take the tube out, so I can turn this upside down. So this here was the B+ side. All right, so it goes over to this side through the transformer. Usually these transformers are kind of crosswayed, so they go kind of in an X pattern. So let's see if I'm right. Yes, there we go. I don't know why they did that. You'll find that in the American radios, this side will be like the primary and this side will be the secondary, or vice versa. And a lot of the European radios, they kind of go crosswise. So something to keep in mind, a little tip for you there if you're working on these radios. So yeah, the transformer here is no problem, and it goes through another transformer down here, and this looks like it would be the plate lead as it's elevated off of this tube here. It probably is. So a 6 CD8. So that should be, I think the plate is pin 6 on a 6 CD8, right? This is a EBF 89. So we should have a lower resistance reading from this side right over to here. And look at that, we do, right? So that's going, the reason it's 12 ohms is it's going through the windings in these two transformers here. And that would be the, I'm pretty positive that pin 6 is the plate lead of that tube. How do I know this? Well, I've worked on these things, and I've worked on European radios a lot. At any rate, so yeah, no plate voltage, right? Because it's going through this resistor right here. And that resistor is as open as it gets, right? Let's see if we can get any resistance readings off this here. Nope. I bet you if I touch it, I touch the probes, I can make it read. Let's give myself a false reading there, right? 12 megs, that's measuring me. That's pretty open. That resistor is trying to become a picofarad valued capacitor right now. So what I'm going to do is desolder this and see if I can find the actual value. I'm thinking 1K, maybe 1.5K ohms, right? So anyways, I'll try and dig up a schematic and I'll be right back. Here's a better view of our little troublemaker right there. So if we look, I managed to find a pretty nice schematic too. We'll take a look at that in a moment. So if we take a look here, we can see that there's a connection right here to a 100K ohm resistor, and that runs off this way. So you can see that brown, black, yellow, 100K ohm resistor. So we know that there's going to be a junction there. So we know that it also goes to the plate of the 6CD8 right here. All right, get that into focus right about there, 6CD8 or EBF 89, okay? So, if we take a look at the schematic, up here we can see the EBF 89, okay, the plate, which is 6, all right, runs here through that one transformer that we tested, and then through the other one, right down here, right, so these boxes, these kind of a dotted line kind of, or I guess you could see broken line, the boxes indicate a transformer case, all right, so one of these cases right here. So if we look over here, you see that there's a bunch of them. There's one here, and I'll get something better to point with other than my big finger here. Okay, so here we go. Use this. I think this is a contact cleaner straw. Okay, so it goes down here. There's one transformer there and another transformer here. So we tested both of those, and we came up with, I think it was 12 something ohms, something like that. So we see there's that 100K ohm resistor. So we have a junction here. And there's the 1.5K ohm resistor that runs off to the B+. All right. So very, very easy to find. This is the resistor here. That has gone bad. That definitely doesn't look like 1.5K ohms, right? The coating on that, it's just all burnt right off. So that resistor has definitely gone bad. So what I'll do is turn this upside down. And I will turn on my desoldering tool, get the meters out of the way and everything like that, and I will be right back. We'll remove that resistor and put a brand new 1.5K ohm resistor in there. All right, I have my brand new 1.5K ohm metal film resistor right here, and my desoldering tool is warm. So let's heat this up. And they bent the lead on this. Got to be very careful with the traces on these older radio receivers because they are pretty crabby by now. Get rid of that. All right. And move this one around. There it is. Ugly old resistor. All right. And we'll put the new one in. Of course, we're going to stand this off just like the old one. So this one here could be bent like so. And like so. Put that in here. Just like so. And I will grab some of my favorite solder I've so comfortably misplaced. Let's see here. There we go. If any of you are looking for verified components lists and my preferred tools and solder and things like that, I have made lists and videos about this stuff up on Patreon, so you definitely want to check that out if you want to see the tools and things that I use. Plus there's another 116 videos up there. So that might be very beneficial if you're interested in restoring older electronics or newer electronics as well. And I also have lots of projects there for you to build and learn from as well. All right. New resistor is in, and it's looking very good. There it is. So now, let's see what happens. Do you think we're going to have to troubleshoot some more, or do you think this thing is just going to work? I'm kind of hoping that it's going to work. Down here, which way does this go in? It's going like so, like so. Okay. That's what's really nice about these. They're so nice and serviceable. Not like a lot of the American radios. They're not so friendly to work with. And they just kind of plug right on in. So that will go there. I think onto this pin. And if I can find the pins it's supposed to line up to, there we go. Just like that. Now I don't even need to put the little plastic rivets or little plastic retainers in while we test this, because if we need to take it back out again because there's some other issue, which I'm hoping there isn't, then it's just all that much easier, right? Just pop this up. So I'll just leave that loose. And of course, if it works, we're doing well. So, okay, so I'll plug this back in. This big dusty case. Back this out a little bit so you can see a little more of this. Let's see what happens. What do you think? Think we're good to go? I have a feeling we probably are. I think I've knocked some of those little plastic rivets off the bench here. I'll have to find them now. Wonderful. Okay, here we go. On it goes. I'm going to turn down the volume. And I'll turn on to FM. FM was surprisingly weak. So let's see if you can see anything that looks good here. Oh, I hear static. And I just am touching the volume. Oh, yeah. It's definitely working now. Lots of music on the FM band. And you know what that means. Alright. Can't leave that on for very long. So move this around here. And I'll see if I can add just a little bit of an antenna to this. That might be beneficial. Do I have a jumper clip or something around here? Give me 1 second and I'm going to go grab a jumper clip. Alright, here we go. Add a little jumper clip to the antenna here. Just lean that over the side. Maybe that'll receive a little better, like so. See if I can. Oh, yeah, look at that. Look at the eye deflection there.
Bruce from Cream on bass, Al Cooper on organ, and the great Harry Nilsson on backing vocals. For years, the master took...
That's working great. AM. Oh yeah, that's come to life. Now there's hardly any reception here, and I also need to change the connections in the back for the AM antenna. Very little reception down here in the lab. So no problems. That's it. Works great. That's all it needed. That resistor was bad. When, a 1K ohm resistor goes into basically infinite resistance, you pretty much know you have it at that point. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. So there'll be lots of repairs, restoration, circuitry design, all sorts of very interesting things on this channel. So if you haven't subscribed, now would be a good time to do that as well. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll pin the link right at the top of the comment section, and I'll also put the link just below the Show More tab just below this video. All right, until next time, take care. Bye for now.